Here's the equipment we're going to use along with a force probe and a lab quest. It's really complicated. You're going to have a little plastic piece of pipe here, and you're going to have, I've already tied on the stoppers to the end of the string, and I've marked the string so that the first black mark, if you hold it at the bottom, you can double check to make sure I haven't messed it up, but if I hold it, keep this black mark at the bottom of my plastic tubing, then the distance from here to here will go 30 centimeters, 40, 50, 60, 70, and 80, and you'll see why we need that in a minute. The icon we want to keep our beat is this metronome icon right there. You just click on that and it pops up. You can't turn it, it only faces one direction. Here's how we set up our iPad metronome. You click on the metronome icon, it pops up. We want 120, well, we can adjust our beats per minute by turning this knob left and right. We want this to be on 1/4, so we want to hit the little toolbox here. First, we don't want all these, we probably don't, if you like that, you can mess around and have a big beat and little beats, okay? I didn't like that. And your tone you can change to get the beat kind of sound you want. I prefer 6, but you can do it any way you want. You can get rid of the pictures of those blocks. If you like those pictures, you can leave them on there. Click on the little 4/4. And we want the note to be, we want the beat off, you want it to be 1/4. And that works. I found that if you do 1/4, then your beats per minute are actually your beats per minute. And that works pretty well. So after you have your metronome set up, you're ready to do the lab. It's really fairly simple. If you look at your table, it'll tell you the radius you need. The first table, the radius will be 0.5. So you can see I'm double checking my distance from my mass to the end of the pipe. It needs to be 0.5, and then there should be a black mark, if I've done all these strings correctly, that you can keep track of and keep it at that radius. So I check it out, I find which black mark I need, and then I'm going to hold the string tight enough to make sure. Now I'm holding the string with the force probe. If you hold the string with your hand, this lab won't work. So I hook there's several loops. You find the loop that works best for your arm length. So I'm not holding that string with my hand. The string is attached to the force probe. And of course you zeroed the force probe before you hook the string on. Okay? And if there's 3 of you, if you might try to find the person with the best rhythm. And I'm not saying that was me, but I didn't have a choice in the matter. Okay? By the way, as you just noticed from that picture, the most dangerous part of this lab is when you stop. If you're not careful, you'll hit yourself in the head with this stopper. So as you're swinging it, do whatever you need. The person swinging needs to be concentrating on the rhythm of the metronome. Now, what we found last time was of course we did 6 people at once, so I guess, although we're going to have 5. If you get 5 of these things in the room at one time beeping, some people it doesn't bother. Some people just about jumped out the window. So you might want to put get some earphones and plug in whoever's doing the swinging. And all they have to do is get it in rhythm. Once they have it in rhythm, then they just tell the person to hit the play button, and which we've done a dozen times, and you should get a nice graph like this. This is where I started up. If you wait until you've got a rhythm, your whole graph should look pretty steady. Okay. Again, you're keeping the black mark right at the place. You're pulling hard enough on the string to keep the black mark right next to the bottom of the tubing, and that'll keep your radius constant. And then you use the rhythm, tap your foot. I found counting helps. I go 1, 2, 1, 2, whatever. You do whatever you need to do to get that rhythm. That's the key, is to making our data come out nicely. Here's a quick reminder of how to change the duration on your lab quest. You've got your force sensor here. You just hit on duration and then hit on duration again and then change it to what you want. If you have somebody wait to start it until, I had it higher because I was doing it by myself. If you wait to start it until the person's in a rhythm, 10 seconds should be plenty of time. And you might even leave it, I think the default is 5, but that's how you change it. And you hit done, then you have to hit OK. For the most part, the lab notebook is self-explanatory, so I'm not going to spend a lot of time on it because I think it just wastes your time. Your mass, that will depend upon your string. Your radius for part 1 will be 0.5 for everybody. I just thought I'd make it simple. Your beats per minute, again, if you set your metronome up right, the 90 beats per minute, then that's time. Divide that by 60 to get beats per second. And if you match that, we're going to assume the person can match that. So that would mean my revolutions per second would be 1.5. And then I multiply that by 6.28 to get my radians per second. We'll always use 6.28 for 2 pi. If you want to use the pi button in your calculator, I don't care. And then you can see in your notebook, you can see the formula that we talked about earlier. The force equals mr omega squared, so that's how I calculate this. And then this is what we measure in our lab. And my percentage difference is between these two numbers. Then after I get all this data filled in, I'm going to do an equation. And your lab notebook will tell you that. I'm going to do an equation. I'm going to put this in the measured one in the y. I'm going to put this in the x. And on the part 1, you need to use the iPad, so only one person has to do it. Put the 0.00 in, and you're going to use the variable power and get a square and find the percentage difference as the notebook explains. That was just a quick overview. The instructions tell you what to do, and the notebook tells you what to do. You'll do a similar item down here, only down here you'll put the radius in the x, and then you'll get a linear equation. You'll compare the slope to the value m omega squared. On this one, you're comparing the coefficient in front of the power equation to mr. And I got pretty decent results when I did it. So good luck.